Me is Aida Sultanali. Stavros Poulopoulos, head of the Department of Chemical and Materials. Chang-Keun, assistant professor, Cevat Erisken, associate professor, and Nuraje, associate professor. So I will start the recording and stop the demonstration, sharing my screen.
So, do you see my screen?
Yes, we can see.
Okay, let me remove the meeting controls there and decrease this one. Okay, 1 second. Okay, hello everyone. I'm Stavros Poulopoulos, head of department and director of UG program of the undergraduate bachelor program. I'm here today with good colleagues from the department, from school office, in order to present the programs, the 4 programs that the department currently offers. Let me move on. Okay, sorry. So I'm going to discuss at the beginning quickly generally about the profession and career prospects, and then I will focus to our department and the chances and opportunities for our students. Let me check my time because I will try to finish everything in 15 minutes. So first of all, what is chemical and materials engineering? Okay, it is the engineering discipline, as you see, that makes use of scaled up, pay attention to this word, scaled up, chemical and physical transformations in order to turn raw materials into the useful and marketable products that we are all using. Or simply, to put it shortly, to improve quality of life by utilizing chemical and physical transformations. And to do so, okay, we use natural resources that we can get. We apply, okay, the principles from a variety of disciplines and science like chemistry, math, economics, even physics and biology, in order, as I said, to deliver these products to our society. And I said before, pay attention to this word, scaled up, and this is what differentiates us from other disciplines like chemistry, for example. We have to move the process, okay, from the lab scale that you see in the first 2 pictures to the real industrial scale. And this is very important. You see what happens today with the vaccine, for example. It's, let's say, one issue to produce something, and it's another issue in order to produce, okay, the material in quantities to satisfy the need, okay, at the world scale. And we are always, you know, at the forefront of innovation because we have to take into account the new needs or new restrictions in our society. You know, environmental remediation remains always a challenge. We have to help to move towards zero emission factories, to assist in developing new materials, even in pharmaceuticals. Yes, we play a role even there. And there is, you know, a lot of room of improvement in the mineral processing industry. The department was renamed from typical chemical engineering to chemical and materials engineering a couple of years ago for 2 reasons. First of all, to depict, of course, the expertise of faculty, because a lot of us are working in developing new materials in different directions, of course. Someone from pharmaceuticals, someone else for solar panels, me for environmental remediation, but we are talking about developing materials. And secondly, okay, to follow the trend, because check this example. the Boeing on the left, 777, was developed somewhere in 1994. 15 years later, a new Boeing 787 was developed, okay, constructed. You see in color the parts from new advanced composite materials, okay. So even if you think that, okay, this is not the typical job of a chemical engineer, still we are involved in the production or development of new materials. And you know, at the end of the day, we also need to know if we will have a good salary to support our families and if there are job positions. For a chemical materials engineer, okay, I can say that it is a growing globally profession. You have a career flexibility as you can work independently as a consultant in a big company or a small company. You may follow the lifestyle that you like. Okay, an adventurous one like the student you see on this photo, it is from our own graduates. Okay, you can stay in your country, you can start your own business, and of course, you can get good money. And to the typical question, who needs a chemical and materials engineer? The answer is very easy, everyone. And let me tell you something, sometimes people are thinking, okay, we can work only in a big industry. This is not for me. But this is not true. Of course, in a country like Kazakhstan, you may follow petrochemical and oil and gas industry and work there. But also you can work in the field of materials. You see biotechnology, generation and storage of energy. We have very nice research directions in our department. In the field of pharmaceuticals, environment, okay, I'm working there. You may work as a consultant, as a health and safety engineer, or in food industry. Or, you know, you may combine our engineering bachelor diploma with the right one at master level, business and finance, and change, let's say, your direction. Okay. And regarding salaries, I have some data from USA because it's easy to retrieve them. We are second only to doctors internationally. Okay, we are talking here, as you see, starting salary for a simple graduate without any PhDs or anything. And this salary steadily grows year after year. And I have a new entry, this slide for 2021 January, very recent data. And you see the mean entry level salary here and the mean annual salary. Okay, you see the position of chemical, classical chemical engineering and material science engineering, of course. Okay, and for example, if you check surveying engineering, you see that they take almost half money compared to our discipline. And sometimes, you know, you may enjoy a good salary, but maybe the field is very competitive. Maybe there are not enough job positions, but this is not the case for us. If you take combined chemical and materials engineer from this table, we see that there are very good prospects regarding job openings. Okay, and if you consider that we have even a master in biomedical engineering, you see that our department can offer you very diverse options. Okay, so you can move between chemical engineering, materials engineering, and biomedical engineering. I have some slides, I will pass them regarding the fact that actually we have even astronauts, okay, going to space, holding a chemical engineering diploma. And my point behind these slides is that we give these skills that will be useful to you during your career path, even during your personal life. Okay, that you will not regret even if you choose to do something else in the future. Okay, the problem-solving focus. Okay, the presentation and negotiation skills that you are going to develop. Okay, there are some quality, some assets that will be useful during your life. And you know the projections about the world population. Okay, maybe we are even now already 8 billion people on Earth. This is a huge number, you know, that poses continuously challenges. And it means that new materials and better processes are essential, and have to be continuously sought if we want to continue enjoying our present standards of living. And chemical and materials engineering is at the center of the new industrial revolution, where economic wealth goes hand in hand with environmental and social sustainability. Okay, I hope, or I believe you have heard the concept of sustainable development. And another question. Okay, Professor, what about Kazakhstan? Is it the right place to study chemical engineering? And the answer is obvious. Kazakhstan is in top 15 countries, not only regarding oil reserves, but almost regarding everything. Uranium, chromium, zinc, copper reserves, whatever you wish, is found underground. Okay. So it is our, let's say, duty, it is your duty, I address specifically the new generation, to take these resources and transform them, into valuable products that can be sold all over the world. And, you know, if you ask my personal opinion, if you are not convinced about money, about prospects and all this stuff, you may become a chemical and materials engineer simply because it has fun. You know, I really believe this. You will enjoy your time in our modern facilities regarding classrooms, computer labs, research labs, and so on. And now, an important question. Maybe we are convinced that chemical and materials engineering discipline deserves our attention. But why at Nazarbayev University? Our department released the first batch of graduates in 2015. Currently, we are running 4 programs, as my good colleagues are going to present you later. We have an international faculty. I hope that I don't have to mention that we are we all hold PhD diplomas. We have research and profiles that you can check in any international database. And we are supported by a good number of teaching assistants, postdoc researchers, lab assistants. We have even the best school office in order to help our students fit in the university. And our program is designed in such a way that delivers solid technical foundation to our students, while at the same time, you will have the opportunity through some elective courses to specialize in aspects of individual interest. And let me present quickly the program. Let me check the time. Because we have 3 more programs. The first year is pretty much common for all departments in the School of Engineering and Digital Sciences. And during the second year, we get a taste of the first chemical engineering courses, like basic principles and calculations in chemical engineering, fluid mechanics, thermodynamics, and chemistry. During the third year, we have let's say, the core chemical and materials engineering courses, like chemical reaction engineering, separation processes, complemented, of course, by instrumental methods, heat and mass transfer, and we need, of course, some fundamentals of management and economics, okay, to help us adjust to the current needs. We have an individual research project before moving to the fourth year, where we have a good number of elective courses, and the capstone project, the cornerstone and the crown of the program, where students are called to utilize the whole knowledge that they got throughout these years and design from scratch, from A to Z, an industrial facility. And we have a number of electives in both directions, chemical engineering and materials engineering, and you may choose whatever you like. Some of them more specialized in specific directions, some of them they give you a general knowledge, okay, about topics of interest, of current interest. So this is another slide showing the path through our program, that following the American standards. Let me tell you this, our program is designed according to US standards, okay, integrating courses from humanities, general engineering courses, of course, the core chemical and material ones, okay, together with the electives that I mentioned. And to accomplish this, I firmly believe, by any standards internationally, we have top facilities, okay, in order to offer lab exercises to our students, classrooms, computer labs. Our students have the chance to participate in international conferences. Okay, it has been suspended for this semester, but pretty soon, I believe we'll go back to normal. And there are many research directions in the department. The colleagues are going to refer to them. I want just to mention that our undergraduate students have the chance to perform real research, and actually now they can even participate officially in projects getting a salary. Okay, it is not about money, of course, at this level. Okay, but I want to ensure you that you participate in real life projects. Okay, and some of our colleagues offer research that it is relevant to society. Okay, so we have both basic science projects and the one that are at a scale close to commercial ones and to society. You see our website. Okay, you may check the details. We are trying always to keep updated the information, okay, presented. And anyway, if you have some questions, do not hesitate to contact any of us. And I'm not going to spend much time. I want to say just that our graduates, they all find a good job, or they pursue further studies in top world-leading universities, the cream of the cream, okay, like MIT, Stanford, Berkeley, and so on. Okay, so you see the bottom line, top universities around the world, okay, they want to get our students in their master and PhD programs. Okay, and I have some slides. Let me show you that there are many opportunities for our students. For student life, we have student chapters, okay, that they will help you, internships, traveling abroad, okay. At the same time, what is important, our students enjoy this experience, okay, you see them in the field. And don't forget their motto, study hard, but party harder. Okay, and closing this one, I want to show you very quickly, okay, real faces, real graduates, okay, not from internet. All the photos that you see in this presentation are coming from our labs and from our own students. You see ISLU, yes, MIT, Agerim, Imperial, Italy, Danil, favorite student. Okay, Ruslan, in platforms, oceans around the world. Okay, Tamerlan, he became a data scientist at Apple. Not good, not bad, yes? Okay, Aslan, Berkeley. Daniyar, one of my first master students when I first joined the Nazarbayev University. Reservoir engineer, working in Almaty. Okay, Azad, working in an international company like Schlumberger. Okay, you see Tahmina and some other students that they chose to stay with us. Okay, in our department. So, closing this presentation, I would say that Chemical and Materials Engineering Department is the greatest place to start your career. And, choose whatever you like in life. It's up to you. But if you believe that you like Chemical and Materials Engineering, do not hesitate, do not think about money, career prospects, and stuff like this. Okay, and if you are trying to find the right place, please join the future, study Chemical and Materials Engineering at Nazarbayev University, study with us. Thank you very much. And I would like now to give the floor to a good colleague, Chang-Keun, who is going to present the master program. Please, Chang-Keun.
Yeah, thank you, Stavros. Okay, now I'm going to introduce about the Master of Science in Chemical and Materials Engineering program, so MCHME program. I'm a director of MCHME program. So in our program, okay, sorry. Yeah, this is needed. So yeah, that's the overview of the master program in our department. So the program goal of MCHME program is providing its a graduate with the skills required for innovative chemical and materials engineering, and to translate research into production and to foster the future technological development in the country and abroad. And the aim of our program is as follows: the educating students with engineers' expertise to lead organizations and provide innovative solutions for complex technical issues of enterprises. Conducting innovative and pioneering the basics of applied research that evolve the body of knowledge in engineering through interdisciplinary collaboration with other schools and research centers at the Nazarbayev University and the leading universities worldwide as well. And advancing the professional development in engineering through our service to the professional community and providing lifelong learning opportunity for the practitioners. So to get the master degree in our department, you should complete 120 ECTS. Among them, actually, there are 5 advanced core courses: applied mathematics, heat and mass transfer, materials processing, and materials characterization, and chemical reaction engineering. And 3 additional core courses are actually research method and ethics, research seminar, and the technical communication. And other, you should complete 4 elective courses to get the MSc degree. And there are 2 another core courses about the thesis research. So the schedule is like this. In the first semester, you should finish 5 core courses about technical communication and advanced applied mathematics, applied advanced material processing, advanced material characterization method, and advanced chemical reaction engineering. And from the second semester, now you are preparing that the research work. So there are research method and ethics core course, and research seminar, and advanced heat and mass transfer. These 3 are the core course, but you can select another 2 elective course from electives pool. I will show you later. And then the semester 3, so in the semester 2, you can choose your supervisor for your MSc thesis, and then you start your research. So the course master thesis 1 is the core course. It has 24 ECTS, so it's major work in this semester, and just you can select 1 elective course. And then semester 4 again, you keep going that the research work and 1 more elective course. Then you can finish all the coursework and you can do the research work as well. So the elective course pools are like this. So the computational and chemical thermodynamics and biofilm and or other many actually options you can select, and then you can study about, depend on your interest. So the big difference between the undergraduate course and the master course is the thesis work. So thesis or dissertation for the PhD degree as well. So you should do some research. So for that, the research work, the first step is identify thesis supervisor. So you can, in the second semester of your master program, there is a research seminar. Then you can, the faculties of our department are providing research seminars. So presentation to you. Then if you have interesting, find the kind of interesting research work from a supervisor, then you can contact to him, and then him or her, and you can discuss about your thesis, and then you can decide your supervisor. And then with discussion with your supervisor, you can select research topic, and then the next semester you should, so it's the third semester of your master program, then you should submit the thesis proposal, and then if approved, then you can carry out your research and the preparation of thesis. And in the fourth semester, you should submit your thesis. So the thesis is kind of a report of your research, and kind of presenting all kind of your research work, research results as well. And then you should present that your thesis work, and to be evaluated by the research your thesis community, the committee meet in the committee for the board on the in front of the board of your research committee. So in our department, in the master program, there is the research topics. There are research topics about energy generation, conversion, storage, and environmental protection, remediation, and the resource efficiency, and process design and simulation, and some kind of functional materials as well. So as our department, head of department already presented about this this figure. We are doing actually energy and bio, and in the field of environment and materials as well, and or many our faculties are involved in different topics. But So from now, I want to introduce about our research topic in master program, but not all of them actually. So part of our research program I will show you. So the first example is like this. So yeah, our department head his group is researching on the environment. So environmental science and technology group. They are researching about that the cost-effective advanced materials for chemical and photocatalytic treatment of wastewater containing water and or wastewater containing pollutant of emerging concern. So emerging concern, which means actually new concern, which means actually for a long time we also considering about different kind of pollutant and how to remove that the kind of pollutant. But nowadays gradually new pollutant also there is. So the emerging pollutant also need to find the kind of way to treat, so remove it or filter out it. So in the present study aims to develop innovative materials for elimination of emerging pollutant in water and wastewater. So that emerging pollutant is, for example, actually pharmaceuticals and endocrine disruptors. And in the master program of his group, they are evaluating the decoupling of GDP, energy, and carbon dioxide emissions. So because the kind of industry are developed and more, then we should use more energy and we should emit more carbon dioxide. So increasing GDP are followed by the energy consumption, and the carbon dioxide emission also can be increased. But that's kind of the harmful in your environment, in our environment. So in his group, they are studying about that, the evaluation of decoupling. So separated actually, so not correlated with the GDP, with energy and carbon dioxide emission. And it can be actually helpful for to make a new strategy about the environment in the government as well. And another approach about that environmental protection in our university is actually prediction of carcinogenicity of polycyclic aromatic hydrocarbons. So this kind of polycyclic aromatic hydrocarbons are generated from kind of industry, or sometimes combustion can make this kind of polycyclic aromatic hydrocarbons, and some of them it have some separated sterically hindered region and isolated double bond. Then they are reactive. They can react with kind of gene, so kind of nucleotide. Then they make kind of mutation, and then it can induce a kind of cancer. So depend on the structure of this kind of material. Is actually sometimes it can happen. It can more harmful for the to induce the cancer or not. So the prediction is important, because if we know that which one is more cancer inducible material or not, then we can make some regulation for that, the emission of this kind of material or not, or treat or also. So in our department, Professor Jorge Ona Ruales are research about this. And another research topic is the energy storage. So as you know, we have a mobile device nowadays. Most of the people have their own mobile device, like a cell phone or tablet or laptop computer. Then all of them have a lithium-ion battery, or nowadays actually more another approach is kind of electric cars. The most important part of that electric car is the lithium-ion battery. So in our department, these three faculties are researching to develop the next generation energy storage system. Their approach is more the master student actually. The master students are more directed to the composite and development of composite anion exchange membranes, advanced battery separator, and polymer electrolyte, and flexible battery as well. That's kind of the membranes. So for the lithium-ion battery as well, we need some kind of membrane system. That the membrane itself is actually just intrinsically that material have porous structure, or sometimes packing of the microparticles can make a porous structure. So Professor Boris Gorman, he is interested in the packing mode of the particle, and then make a channel to make the porous material made of made of that particle packing. So the analysis of packing structure of powder compact and other kind of the material transporting system in that porous material, also research in his group. And especially for me, actually, I'm developing energy transforming and optoelectronic materials. So even we have good solar cells, so the silicon solar cell is until now is the most successful model for the commercialized solar cell, but their active layer, this is the solar spectrum, but that the silicon solar cell can only cover actually this region only. So this area of the solarite and this area of solarite is waste. So in my research, actually, energy transforming experiment research, actually, we transform the energy from this outer the energy to the inside of the active silicon solar cell area. So lower energy convert to the higher energy, and higher energy convert to the lower energy. We can convert, and then we can use. Then we can improve the solar cell efficiency. And so novel optoelectronic materials also we can develop and then apply to the solar energy materials. And also we are doing actually kind of food industry also we are research. Professor Sergei Sporter, he is developing smart drying method actually that in that so actually in Kazakhstan our climate is quite dry, then so it's very good place to dry that to dry some kind of food also. But in conventional actually the dryer, so partially dried and some part is not dried well. That's why he's designed this kind of the Vortex Dehydrator. So that is in that the dryer, the air are airflow actually kind of spiral direction, and then he can homogeneously dry this kind of here it's actually a ring of the apple, and then so we can we can produce kind of dried food as well. Here another one is actually it's very important to work for the chemical engineer, so that is process simulation. So Professor Dawar Shah in our department, he is designing chemical process the kind of production process sometimes with actually Aspen Plus software. Yeah, this software, if you are, the companies are like actually this kind of some engineers who can utilize the Aspen Plus. So it's very useful tool for chemical engineer. So in this example, actually, he's developing kind of core combustion method, so kind of core combustion power plant. Yeah, it's actually old technology, but and it have some problem because of the pollutant and kind of another low efficiency as well, actually, that have some problem in this core power plant. But he developing actually that the boiler system to with Aspen Plus software. He's modeling and then make an efficient method with the software modeling method. And here we have another computer simulation study with Professor Yanwei Wang. He's developing, kind of finding a way to simulate materials, all kind of materials. So the paradigm of the thinking in the development of material is at the first time is actually empirical science. Oh, yeah, time. So at the first time only experimentally dependent, and then we explain this the phenomenon with theoretically, and then nowadays we are doing actually computationally. So experiment and the computational study together going. But after then, nowadays, so new technologies, big data technology, so which means that AI can design the material, and then we can fabricate the design. So it's from the empirical, so experimental design, and then nowadays actually, computer can design the material, and with the this kind of computational tool, he developing many different kind of scaled material and material interface. Also, we are studied in our department. So that's a part of our research topic in master program, and or other I want to say thank you for our faculty to develop for the contribution of this presentation and the step of our school. And thank you for the audience as well. So that's it for me. And then I need to this presentation should move to Cevat. Cevat, could you?
Yeah. Okay. I'm just trying to share the screen. I don't know if it worked out or not. Let me see. Oh, here it is. Okay. I just need to enlarge the screen. Okay. So hello, everyone. Today, thank you to my colleagues for initiating this, and I'll be talking about biomedical engineering. Okay, Stavros earlier said that we have 3 different programs: chemical engineering undergraduate, chemical engineering master's, biomedical engineering, as well as PhD. So this is part of biomedical engineering. So for those who are new to biomedical engineering, I would like to give the definition of biomedical engineering. So Stavros talked about chemical engineering. So what is a biomedical engineer? It's just like a normal engineer, but it is just a little cooler, okay? Because the name biomedical makes it a little cool, right? It deals with the application of the principles and problem-solving techniques of engineering to improve human health. Okay, so we are learning here how to approach a problem and how to solve a problem to improve human health. Okay, so what do we do as biomedical engineers? We design, develop, and test all aspects of medical and surgical instruments. Okay, and we also analyze the failure and take the corrective and preventive actions to respond to customer complaints. We also demonstrate operation of equipment to medical personnel. Actually, technicians are doing it, but we are training the technicians to demonstrate the operation of biomedical instruments. We also work with like cross-functional teams to test prototypes. So as engineers, we first perform an experiment and then we end up with a prototype. We test it and then it is being commercialized lastly. Okay, so what do we offer at Nazarbayev University about the master's degree in biomedical engineering? I'll not spend a lot of time on this because it is already available online in the handbook, program handbook. You can find it easily. But we have like 4 semesters in total. It's a 2-year program. You have the core courses required, and you will have elective courses. You have 4 electives in total. What we have here, I would like to pay your attention that we have MBME 303. This is the Biomaterials Science and Engineering. Then we have Biosensors, Anatomy and Physiology for Biomedical Engineering. So these are the core courses, including, of course, Advanced Tissue Engineering. So this is my field, actually. So what we offer as elective courses are like the students are learning the strategies for controlled topical delivery of drugs, medical device technology, infectious diseases and antimicrobial strategies, biomedical imaging, as well as mechanics of living tissues. Of course, this is the living list. We update this list, based on the needs. And as we increase our faculty members, as we increase the number of students, we are going to increase the elective courses to be offered. Okay, so the main fields of biomedical engineering. Biomedical engineering is actually everywhere. It's very similar to chemical engineering. Okay, we have bioprocessing, biomaterials, physiology, biomechanics, imaging, regenerative engineering, bioinformatics, rehabilitation, biosensors, instrumentation. So these are all main fields of biomedical engineering. I'll try to touch upon each of these really briefly because we don't have a lot of time. I'll try to be quick. Okay, the first thing is the biosensors. So for those who are new to biosensors, it is the result of bioreceptor and the transducer. Okay, bioreceptor is a biomolecule. Let me just enable the pen function or highlighter. So yeah, bioreceptor is a biomolecule that recognizes the target analyte. Okay, we are using this procedure for detecting the presence of COVID-19 marker, okay, in the body these days. Transducer, on the other hand, converts the recognition event into a measurable signal. Okay, you may detect something in the body, but it has to be something measurable. Okay, so this is what biosensors field is related to. We have Professor Daniel Tosi in the biosensor field. So he's currently performing studies related to fiber optic biosensors. I will not go into details, but you can certainly go to his website and look for more details if you are interested. So he is actually sensing the environment around the fiber here, you see, and by incorporating different receptors, you can functionalize the fiber, for example, to catch different molecules. Okay, another area he's working is thermal ablation. So you can actually remove tumors in the body through thermal ablation. So ablation is basically like eroding a material or eroding a tissue in the body. Then we have biomaterials. These are the materials that do not lead to adverse reactions. So these are regular materials. We call them biomaterials because they are not leading to any adverse reactions, or they are leading to reactions that are at acceptable levels. Okay. We have several biomaterials in the body, for example, joint replacement devices. So this is a device that is used to replace the knee joint. So basically, this is the knee here. We have heart valves, artificial tissues or organs, dental implant, adhesives, bone implants, stents, etc. So these are all some of the examples of biomaterials that are present in the body. Okay, then biofilms. This is an important field of biomedical engineering as well. It deals with the infections. Okay, the infectious agents. This is the loop, the progression of the infection in the body. Okay, first we have the adherents, the pathogens. They adhere on the surface. They then initiate the process of multiplication and maturation, and then they start dispersing into body. And we have to prevent dispersion of these, even maturation and initiation stage. We cannot do anything maybe, but maturation and dispersion stage, we have to get it involved. Otherwise, these are multiplying at such high rate that the cells may not be able to cope with them any longer. So we have to take precautions at an earlier stage. Imaging is another field. Okay, it's about combination of physical phenomena like sound, radiation, etc., with the data processing and displaying the results. So some examples are, you may be familiar with X-rays, right? Most of us went to an orthopedics department to get our heart tissues imaged. So X-ray, computed tomography, ultrasound. So this is an example of ultrasound, and this is the example of MRI, and so on, X-ray, and also computed tomography. Okay, so these are some of the fields in the imaging. Chang-Keun is also working in partly in the imaging section. He's doing like theranostic materials, working on theranostic materials. These are therapeutic materials and diagnostic. So they are used for diagnostic purposes and therapeutic purposes. So his motto is like see and treat. First, you have to see it in the body, then you can treat it. Okay, and he's trying to develop materials that makes the unseen objects in the body visible. Okay. Bioinformatics, this is also an important field. We have people working in the field in our department or in other departments at Nazarbayev University. So it's the field of science in which biology, computer science, and information technology, they come together into a single discipline. Okay, this is also part of biomedical engineering. Knowing about these figures here tells us how much the bioinformatics field is important and what it has to offer in the field of biomedical engineering. So the global bioinformatics market is projected to reach about $15 billion in 2023, from only like $6 billion in 2017. So this is a huge progress, or huge progress in the field of biomedical engineering. Then we have regenerative engineering. This is about the application of biological, chemical, and engineering principles. So it involves different disciplines like basic sciences, medical sciences, and so on, to repair, restore, or regenerate the tissues using cells, factors, and biomaterials, either alone or in combination. Okay, so these are used together to restore the functions of the damaged tissues. So this analogy could actually help. Think of a car with a damaged car. So what do you do with it? You don't simply take it into the junkyard, right? You take it to repair, to mechanics, and they are repairing the car so that it looks like an original car. Okay, so regenerative engineering actually uses similar analogy. Okay, it implies that the quality of human body could be improved by replacing of its parts, just like it is done for a mechanical device such as a car here. Of course, human body is different from a car, because car is a mechanical device, but human body is a dynamic environment. Okay, we have a living environment, so there are differences, but the analogy is similar. So in this area, Dana, she is working on the 3D printing, bioprintings to develop like bones for the human, and also for replacing a bone. So 3D printers are currently available techniques that can actually precisely print the shape of the damaged organ. Say you have a damaged bone tissue, it could be related to an explosion or trauma or maybe military reason. So the damage could exactly be scanned, and then you introduce the scan into the software, and the printer can actually print precisely the same shape. So Meniscus Regenerative Engineering, this is myself. You can apply regenerative engineering to different areas like bone, tendon, cartilage, ligament, meniscus, and for all other maybe tissues and organs. So this is an example about the sheep meniscus. What we have, we created a damage on the sheep meniscus, and then using 3D design, we got the file, electronic file of the shape, and then we 3D printed this scaffold. So it is a graft. Next, what we did actually, we replaced the healthy tissue. We created a damage to the sheep knee. You see it here in this image. Okay, this is actually the scaffold. The white portion here is the meniscus, and you see it with the sutures. Okay, I'm talking about this part. Let me just change the color quickly. Yeah. Okay, so this is actually the meniscus. You see it in the sutures. So this is the 3D printed meniscus here. You simply implant it into the sheep knee in order to see whether it's going to be functional. Of course, this is a detailed study, but I don't want to take your time and spend time on this. Later on, what we did actually after 6 weeks, okay, you see that the sheep can actually walk around. Oops. So what I need to do, I believe I need to quit the full screen. Oh, okay, here it is. Yeah, so as you see here, the sheep is healthy, and the biomaterial or 3D printed material we used, we implanted into the sheep, did not lead to any side effects. Of course, it has positive effects, and you can actually, we can discuss it later on if you like. Okay, so what about career options in biomedical engineering? If you look at this pie chart here, oops. Okay, the pie chart here, it shows, I cannot just use the, give me a second, yeah. Okay, so the pie chart here, it shows the distribution of the graduates of chemical, of biomedical engineers in the field, in industry. So most of them are going to industry, as you see here. Part of them go to medical school, they perform master's degree or PhD degree. Okay, they work in the industry, consulting, government agencies, hospital, medical device, medical equipment, and they also have some specialty in product development and so on. So basically, biomedical engineers work everywhere, but they cannot work as a surgeons, by the way, but they do a lot of medical related jobs. Okay, degrees by discipline. So this is a complementary table maybe to what Stavros demonstrated us. He showed that chemical engineers, biomedical engineers, they have the top salaries in the field and projection up until 25. There's going to be a need for biomedical engineers as well as chemical engineers. This table shows the undergraduate the student enrollment in different levels, undergraduate, master's, and PhD degrees. So if you look at the biomedical engineering, this is the change between 2008 and 2017. This is the latest available data because they don't they don't publish reports every year. Okay, maybe in the next 10 years, like 20 something, we will be able to get new data. Look at the results here. The highest increase in the number of student enrollment is in biomedical engineering, in chemical engineering, and in computer science. Okay. In master's level, we have the computer science and also the biomedical engineering. in terms of PhD, biomedical engineering is actually at the top. Okay, so this tells us that now the people are getting more and more interested in biomedical engineering, and in the near future we will see the products, and we'll have a lot of graduates in this area. And the reason is that there's a need for biomedical engineering, and there is going to be a need for biomedical engineers in the next 10-20 years. Okay, so yeah, I believe I used my time efficiently, and thank you for listening. If you have any questions, we can discuss it later on. You can always send me an emails, and I'll try to respond to it by the best of my capacity. Okay, thank you, everyone.
Stavros, do I have time to present PhD program? All of you used up this time. Do I have time to present right now?
Yes, please.
Yes, you can go ahead.
Okay, my name is Nuraje. I am associate professor in a Department of Chemical and Materials Engineering. So I am in charge of PhD program in our department. So PhD program, the goal is to develop high quality doctoral researcher ready to able to make a lasting contribution to address scientific, technology, economic, societal, environmental challenge of global significance. So this goal is closely associated with the aim of Kazakhstan to increase its global competence and join top 30 most developed country in the world by 2050. So program trying to prepare specialists for advanced careers in industry and academic in Kazakhstan, also other countries. Also, this program also trying to prepare like future policy decision makers for careers in the governmental agency, public service, and the social economy in Kazakhstan and globally. So this program also trying to prepare like entrepreneurs who will be able to promote advanced in innovative science-rich technology anywhere in the world. So, and then we also try to prepare new generation of commercially available and technology advanced scientists and technologists. And then we're also trying to prepare like future academic and researchers in chemical engineering subdiscipline in University of Kazakhstan and the other part of the world. So program outcome. So we want to expect our students after finishing this program can review and analyze, evaluate the scientific literature in the field of chemical engineering. And also students should have ability to select research topics in the field of the chemical engineering and generate hypotheses, aim such topics. And then we also expect our students to plan and develop, analyze, and communicate research in writing and verbally, independently. And then also we expect our students to like make original contribution to in the field of chemical engineering. We also expect our students to judge technically and ethically related research topic in the broader knowledge in chemical engineering. We also expect our students to like develop their academic and scholarly career through presentation, publication, and national and international networking. Okay, so how we recruit our students. So PhD student recruitment process is conducted by 2 units. One is the Nazarbayev University admission office. Another one is the PhD admission committee from our department. So students need to submit application package by the deadline. So application package includes online form and the cover letters. Cover letter is basically the motivation letter why he wants to join this PhD program in chemical engineering department. And then applicant needs to provide certificates of bachelor science and master science in chemical engineering related fields. And then students also need to provide their English proficiency. So like it needs to provide IELTS, like at least it needs to have 6.5 grades, marks. And then applicant needs to provide like recommendation letter. I think at least we require 2 letters from reference And then, of course, they need to also upload their resume. So after the students submit their application package, our admission committee will review it, and then selected candidate will be invited for personal interview. After interview, based on our selection, we will offer the acceptance letter. And then, so here's our requirement for PhD degree. So students to get like PhD degree, they need to finish like at least a total of 240 ECTS. So what's that mean for ECTS mean? Like European Credit Transfer System by the end of program. So our PhD program is designed for 4 years. So this 240 ECTS include like at least like 62 ECTS in the taught courses and the 178 ECTS from research work. So PhD students required to take like 5 core courses from our department. Here's the way listed, like advanced chemical reaction engineering, thermodynamic, heat and mass transfer, also current research literature, and the 1 school required core course. And then we also requires 3 elective courses from our department. So this is a list of our course for first year. So students needs to take this core courses, also elective courses. So you can find out this information from our online. And then, so first semester you need to register for at least 24 ECTS, maximum of 36 ECTS. This is a list of the courses offered by our department. This first 5 courses, core courses, rest of 9 is like elective course. We are still updating this elective course part. And so after students finish academic course, after finish this course, they need to look for like find out like supervisor. So in the second semester, starting from second semester, after then, students like at the end of first year, students need to pass subject qualifying exam. And then a third semester, students need to pass thesis qualifying exam, like oral defense. And then students will become like candidate for the PhD program. Students need to conduct research under supervision of their advisors. And then the annual progress reviewed, monitored by progress review committee annually. After with approval of advisors, these students need to submit their thesis to Thesis Examination Committee in the middle of 8th semester. So our department graduate program committee helped students to establish 3 committee, like subcommittee. So first one is the supervisor committee. So supervisor committee consists of lead supervisor, co-supervisor, and external advisor. External advisor from outside of NU. So at the end of first year. So this supervisor committee basically is help students to succeed in their research. And the second committee is the progress review committee. Progress review committee is conduct the thesis oral proposal defense at the end of third semester. Also monitor students' yearly like progress. So this committee is made of basically chair of the departmental graduate program committee, also 1 faculty from SEDS. And then third committee for students is the Cis Examination Committee. So this committee will be in charge of like dissertation thesis defense, and then also check their dissertation. And then in this committee, 1 member has to be from outside of NU, should be the expert in this field. Okay, so completion requirement, very important. Students has to stay in good standing. So at least the minimum collective GPA is B- or higher than B-. And then students, I already mentioned, has to pass subject qualifying exam. And then by third semester, he has to pass research proposal defense. And then also has to satisfy annual progress review by PRC. And then students has to finish all of the required research work for dissertation. It's very important. And then very important, one also requirement I want to mention here, he needs to publish at least 1 article in the scopes like Q1, Q2 journals. After approval from Thesis Examination Committee, students can submit their thesis and then finish their PhD study. So here I listed our PhD level research topics. So we have basically classified in the four fields. First one is the energy generation, conversion, and storage. Second is the environmental protection, remediation, resource efficiency. Third field is the process design and simulation. And fourth area, functional materials. So in this research topic, I think Professor Lim and Cevat Erisken give a very detailed introduction. But here I just give some examples in our PhD student working in topics. So I don't want to go detail. So one of the area is that developing like advanced materials for photocatalytic water treatment or in environmental remediation area. So another area I want to point out, like a third year students working from Professor Jumabai Bakanov and Alma Gumentayev group in battery. Here's some work I want to mention is second year students from in the same group from Professor Jumabai Bakanov and Alma Gumentayev group working on this another area like sulfur-based battery. Another slides I want to mention first year students also working on also similar type of this battery field. So this slide you already seen. So you can find more information our research interest of faculties through visiting our webpage. Thank you so much for your attention. If you have any questions, I am happy to answer.
Thank you very much, Professor. So dear participants, so if you have any questions.
I think I spent 15 minutes or 10 minutes. 10 minutes looks like.
Okay, so guys, do you have any questions about the program, about admission requirements, about the content? You are more than welcome. Okay.
Yes, Abdul, please. Yes, you can switch on your turn on your microphone and ask for your question, or you can write in chat box.
Yes, Abdul, we're waiting for your question. Okay, if you have also any other questions, you can write to our email. Lunar will provide you in our chat box the address of our email. Also, if you do not have any other questions, Lunar, can we start our quiz?
Yes, of course. Dear participants, I you can find our email in the chat box, so please address all your questions regarding the admissions, regarding the program contents to our email, or you can ask it right now as the professors are here and they will be happy to answer all your questions. If there is no questions, let us start the quiz. So we will have this quiz and we will find out the one winner who will win our t-shirt and black note with the logo of SEDS. Unfortunately, due to the COVID situation, we are in Astana now, so in Nur Sultan, we cannot deliver it. We have some problems with logistics. So, but if you will win, I will. You can take your prize from me. So let me start it. So here you can see the rules for our quiz. We will have 5 multiple choice questions. Please read the question with the answer variants. Write in the chat box all the 5 questions in one message. So it will be for us more comfortable to find out who will be the first. So the first participants will get the prize. We wish you all the good luck. Please participate. The questions. The first one, what is the duration of the Chemical and Materials Engineering and Biomedical Engineering master programs? A, 1 year, 2, B, 2 years, C, 3 years, should be, sorry, it's my typo, and D is forever, so you should choose the variant which is correct. The second question, which of the following is related to biomedical engineering? A, biosensors, B, biomaterials, C, tissue engineering, and D, all of the above. Let us move to the third question. When do we celebrate the Nanotechnology Day? A, October 9, B, October 20, C, December 3, and D, January 6.
This question is relevant, okay, to the scale. Consider what is nano to answer, okay?
The first question, you have to find out the main research directions of the Chemical and Materials Engineering department. So, A, cybersecurity big data analysis, B, maintenance planning and project management, C, energy, bioenvironment materials, and D, construction materials, rail transport. So here are 2 questions. And the last question, what is the best place to start your engineering career in Central Asia? A, Chemical Engineering Department at MIT, B, Chemical Engineering Department at Stanford, C, Biomedical Engineering Department at the University of Rio de Janeiro, and D, Chemical and Materials Engineering Department at Nazarbayev University. So now we are accepting the answers. Please write it. Nurbol, thank you. Anyone else who will participate?
Nurbol, I believe, was correct, right?
I suppose.
The last one was a bit a trap question.
It was difficult.
Some of us would go for Rio de Janeiro, but no, it's Nazarbayev University.
Okay, here are the answers. Let us check it again. So the duration is, oops. So, Emmanuel, thank you very much for participating. So here are the answers. The first one, the duration is 2 years. The second question is all of the above, D. The third one is October 9. And the fourth question is C, energy, bioenvironment, and materials. And the last one is, of course, Nazarbayev University, the School of Engineering and Digital Sciences. So Nurbol was, oops. Yes, Nurbol was the first. Nurbol, could you please write me your email? We will contact you to give the prize. I can see that people are joining. Dear participants who are late, thank you very much for coming. You can find the presentation at our YouTube channel. I will give it here, the link. Dear professors, thank you very much for the presentation. It was really interesting, lots of details. I'm sure that everyone who are interested in this major will find everything in this presentation, in this video. Dear participants, thank you very much for being with us. We will be happy to see you among our students. So if you have any questions, please write it to our email. Here it is. Abdul, okay. Abdul, yes, we will wait for your email. You can send it. Thank you very much. Have a good evening. Have a good weekend, everyone. So bye-bye.
Thank you.
Bye-bye.
Stay safe.
Bye.
Bye.